Welcome to our first Prelab video here of the semester for our 1211 lab sequence in North Georgia. What we're going to be taking a look at today is a couple different measuring devices and how we actually apply significant figures to making measurements in a laboratory setting, ranging from things like a ruler, making measurements of length, to measuring volume with some different tools that I have here in forms of glassware, such as graduated cylinders, which are going to be a little bit more precise. That's why they have kind of more in-depth kind of tick marks or calibration markings on them for us to be able to measure volumes, in comparison to, say, maybe an Erlenmeyer flask or a beaker, where our actual calibration lines are a little bit more spread out and aren't going to give us quite as precise in measurements in terms of the number of significant digits we can report for them. So with that said, we're going to take a little bit more zoomed in look at each of these to look at, one, how we use them to make measurements, but also then how we report significant figures for each of them and how they are a little bit different. All right, so first up, as far as kind of looking at our tools for measurements, we're going to just look at simple rulers, measuring lengths, and kind of point out a few things when it comes to the metric system versus, say, measuring things in inches. That'll kind of allow us to apply sig figs in a way I think that makes sense for using the metric system, which is what we tend to gravitate towards in most science labs. So looking at the ruler that we have right here, we'll notice that the very top line that's on this is kind of got tick marks of every millimeter, with the larger numbers like the 1, 2, 3, 4 readings being in units of centimeters. Is effectively what they're trying to kind of show with the labels that are over here. Now, our goal as far as using this to make measurements, we're looking to try to line up kind of the edge of whatever it is we're measuring the length of. Let's say I'm measuring the length of this piece of white paper. I'm just matching the very end line over here to kind of the start of the white paper itself. And then we're seeing where do we end up at over here, and like what tick mark are we closest to. And the one thing to really point out about significant figures when making measurements where you have calibrated markings like this is your last decimal place that you would report should always be one decimal place further than whatever the tick marks are themselves. So if I was giving this measurement, say, in centimeters, right now all of those little tiny tick marks that are here are every 1/10 of a centimeter. So like 0.1, which means if I was to report this measurement, I would actually want to give it to 2 decimal places in centimeters. So if I was looking at this measurement, say over here kind of on this right-hand side, I'm looking at that where that paper ends is almost exactly on that 4th tick mark after the 7. And so I wouldn't just say 7.4 centimeters. If I think it's exactly on that tick mark, I could say 7.40 centimeters. Or if I didn't think it was quite to that tick mark, I could say 7.39 centimeters. And that's really kind of how sig figs work. It's the idea that that very last decimal kind of has some flexibility to it, right? It's going to have some uncertainty is what we usually refer to it as, due to the fact that whoever's looking at that, trying to make that measurement, the way the angle they might look at it might fluctuate enough to actually cause a very small difference in the estimation of what we're trying to measure there. And so if I was writing this down, I would probably say 7.40. If someone else said 7.42, that's not wrong. That's just what they measured for that. It's kind of understood that that last decimal place is a little bit of an estimation. And so there's going to be a little bit of kind of like plus or minus kind of margin of error to the measurement that you're giving when you give it to that many decimal places. But that's kind of the point. I don't want to say that I have this to 7.4, like 000, centimeters, because I don't have enough tick markings on my measuring device to have that many significant figures of accuracy in what I'm trying to do. Similarly, if I was measuring this in millimeters, like the individual tick marks that are there, really now would be more like 74 I could say 74.0, or again like 73.8 or 74.2 or 74.1, like whatever you think, wherever you think that tick mark is. But it's important that you're always going 1 decimal place past where those tick marks are. So again, on centimeters for a ruler like this, every tick mark is 1/10 of a centimeter, so I should be able to give 2 decimal places to any centimeter measurement. If I was reporting it in millimeters, it would be to the nearest 0.1 millimeter, because every individual tick mark is 1 millimeter on this ruler. Now, if I was to flip this and say, look at the inches side of the same ruler, it's a little more complicated, particularly when it comes to significant figures. And it's why we tend to not use them as often in a lab setting, because it's a little bit more awkward to make kind of precise measurements with. Because if we notice here, the tick marks for inches, they aren't every like 1/10. And so everything's not segregated and divided by 10 or into 10 pieces of 1 like everything is for kind of normal SI units in the metric system. And that does make for a little bit more complication when trying to take a device like this or just a measuring tool like this and try to give an actual numerical like decimal reading for the measurement that we're making. Right? For this, I can tell it's a little less than 3 inches over here. Looks like it's maybe really close to 2 and what I would say maybe 5/16 of an inch. Because if you look here, every little tiny tick mark is a 1/16 of an inch, but that's not a decimal number, right? It's still a fraction. And if you actually go and convert that to a decimal number, you're going to get something that's going to have a lot more decimal places than what we probably know this to accurately in terms of significant digits. Now, in the actual lab itself, as you're making your measurements and recording them, you might end up recording and reporting something like if it's 1/16 or 3/16 of an inch that you're measuring, like, yeah, we're going to have you write that out to 4 decimals just to kind of give some inches to centimeters comparisons. But do be aware, that's not really accurate in terms of sig figs. Right? Sig figs are much easier to express in terms of like in the metric system, where our rulers or kind of measuring tools are often kind of calibrated to that metric system in a way we can read them and write down an actual decimal number from what we visually see. Here, that's much more difficult to do with the inches measurements. Again, I would probably say this is 15/16 of an inch, and then we could convert that to a decimal from there. But that, if we write out all those decimal places, that's not necessarily reflective of how well we know that measurement based on the tool that we're actually using. So that is one reason why you'll see a lot of times, like, scientific standpoint, when we're making measurements in a lab setting, it's probably not in inches, it's probably going to be in the metric system with millimeters or centimeters for most things. All right, so swapping from looking at length to looking at measurements with volume now instead, we're going to look at kind of some of our different measuring tools here for volume, starting with the graduated cylinder that we see here. When it comes to making measurements with the graduated cylinder, these are a little bit more accurate than we're going to see out of beakers and flasks. But the number of significant digits we're going to report is actually still going to be dependent, again, on kind of where our ticker calibration marks are for that particular graduated cylinder. So we'll notice here it ranges from, say, this is like 20 up to 30 cubic centimeters or milliliters, which are the same as a unit. So the tick mark is basically every 1 milliliter. So for this particular graduate cylinder, following the same rules we did before, if we can go 1 decimal place further than our actual graduation marks on the cylinder itself, then we should be able to report to the nearest 1/10 of a milliliter. And so the way we read things then is that we're going to look, we see kind of this, it almost looks a little bit like a bubble, but it's kind of like a U shape here of our water. We're going to try to read the very bottom of that U shape here, which you see like the bottom of this line, kind of what I'm trying to indicate there. And that's where we're going to try to make our actual measurement. And so if I look on the tick marks of kind of where that falls, kind of starting up here, right, like this looks like it's maybe about 15, 16, 17, 18. It's awfully close to 19 milliliters. And that's, again, the last decimal place has some kind of variation to it. It's kind of our uncertainty. And so if, for me, I'm going to read this and say that maybe I think this is 18.9 milliliters as a volume. Someone else might read the same thing and say it's 19.1 or 19.0 milliliters. Those are all fine. That last decimal, we understand it's going to be kind of our best estimation. So there's going to be some variation in what different people might actually record that measurement as. But again, 1 decimal place further than the graduation marks is kind of that habit we always want to be in when we're making these measurements. But other graduated cylinders may have their tick marks to smaller than a milliliter values. Right, so this first graduate cylinder that we're looking at was a 50 milliliter graduate cylinder. If I switch that one out and replace it with one that is only a 10 milliliter graduated cylinder, here we see like our tick marks, basically the larger values. We can see the markings for 1, 2, 3, 4, 5, 6 milliliters on this graduated cylinder. And then there's 10 smaller individual graduations between each full milliliter. Now that means if the graduations go to the nearest 0.1 milliliter, our reported value can go to the nearest 0.01 milliliter instead. So again, if I was making a measurement here looking at my meniscus, I want to look at the bottom of that U, that what we call that meniscus shape that the water has inside the graduated cylinder. And so from the bottom of that, I think it's a little bit below the marking, just below 6 milliliters. So again, I might report this as, say, 5.88 or 5.89 milliliters. Someone else maybe says it's exactly 5.90 milliliters. But it's important that you would report it as 5.90, not just 5.9 milliliters. There's a difference when you give that extra decimal place to trying to tell someone else for how precise that measurement actually is, right? If you say it's 5.9 milliliters, well, that means it could be 5.7, or it could be 5.8, or it could be 6.0. But looking at this graduated cylinder, we know it's not above 6, and we know it's definitely not below 5.8, right? So it's got to be around 5.9. We could say 5.90. Now we're assuming that estimation or that uncertainty in that very last decimal, that last one may vary a little bit, but that means maybe the actual value is between like 5.86 and 5.92 or something, somewhere in that range. But by giving the number of decimal places that we give for that measurement, that's giving us kind of an idea of how well do we actually know what that measurement is. Right? And that's why we typically use graduated cylinders to make these measurements. They're a lot more accurate, say, than beakers or flasks, which I'll take just a quick peek at in comparison. If we were to put, say, a beaker up here, we'll notice that your tick marks on a beaker are not nearly as prevalent. There's not nearly as many of them. We have it just every 10 milliliters for a tick mark. So if I was going to read that volume, well, it's definitely between 20 and 30, but I can't say with any kind of definitive, oh yes, this is 25.00 milliliters for this volume. There's no way for me to get that kind of accuracy measuring with this beaker. Right? It does look like it's maybe around 25 milliliters. It's definitely between 20 and 30, but we don't really have more significant digits to give other than maybe just the ones place in the milliliters. So if someone said 24 or 26 milliliters, that's probably fine here. But we don't have enough tick marks or calibrations on our measuring tool to be able to give more decimal places to the number that we measure. And that's really one of the major things this lab wants to highlight, is just getting in the habit of how many significant digits should we be reporting. The fact that it's usually one decimal place further than your normal calibration marks or tick marks on that measuring tool. And getting in the habit of things like graduated cylinders, better than beakers or flasks. Which means if you're measuring out a volume in this class, if it's a volume that number matters for, you probably want to use a graduated cylinder. If it's just a generic about 30 milliliters, and it doesn't even say like 30.0, it just says about 30 milliliters, you can just use a beaker to measure that out, because that amount probably doesn't matter exactly for what we're doing. So that gives you kind of some introduction to like how to pick a measuring tool a little bit as well. Some other things like that sort that you'll see as we get into the experiment itself. But that's all I have this time for this pre-lab video. We'll see you next time for our next lab when we get into density.